Hello, I'm Zan-Misel Κουστώ. Welcome to Stories of the Sea. 30 years ago, the exploration of sea and space was well underway. And today, while most people are aware of the history of the space program, few know about the exploration of the ocean. Starting in the 1960s, there were a number of programs in which man lived in undersea habitats on the ocean floor. We'll look back at these experiments that tested the ability of man being able to work, sleep, and live for long periods of time underwater. Join us as we explore the Earth's final frontier and recount our effort to colonize the sea.
The ocean is a strange and awesome power, and it took mankind literally thousands of years to summon up enough courage to dive below its surface and into the very heart of this mysterious, watery other world. Once he entered this almost cosmic other world, the world below the sea, he saw for himself just how incredible it really was. Such a strange world, as alien and as foreign as the most distant and exotic planet in outer space. There was, he discovered, a place on his own planet that was an absolutely unique area, so odd and different from anything he'd ever seen before, and it was just waiting to be explored. Then, for hundreds of years, he struggled with the problems of actually exploring this world. He invented a whole array of different kinds of diving methods and equipment to be used for exploring this new territory. Yet each had severe limitations, and each of these limitations had to do with man's inability to breathe underwater. First of all, he needed special equipment to help him breathe. But so far, the gear he had was terribly restricted and would only allow him to breathe for short periods of time. No diver could remain submerged for very long before he'd have to resurface to replenish his air supply. Consequently, there was a significant limit to what man could explore. Somehow, he needed to discover how he could stay submerged for a much longer period of time. His inventions and experiments were numerous. Some of them succeeded, many others failed. He did, however, become convinced during his struggle that in that world deep below him, there were fascinating, even magical stories that awaited him. The secrets of the dark, eerie, bottomless ocean were, for then, only fragmented visions of his imagination. In modern times came hard hat divers. They could stay down longer, but not significantly. Following them, there was a scuba diver, but they were severely restricted by the capacity of their air tanks. Then an invention came along that revolutionized the exploration of the ocean. When the submersible vehicle, or submarine, was invented, it gave mankind an opportunity towards staying submerged for long periods. But for truly deep exploration, it still didn't allow him to study this amazing world long enough. There had to be another way for scientists and researchers to submerge themselves for periods long enough to bring back new information. There was. In 1964, just off the coast of Bermuda, America launched its first serious attempt to establish a working habitat for researchers. This habitat could be lowered into the ocean at varying depths and would actually allow researchers to eat, live, and work in it for an extended period of time. It was developed by the United States Navy and was called SeaLab-1. Its primary purpose was to investigate the various problems of people breathing an artificial atmosphere. Their problems enduring tremendous pounds of pressure that would be exerted on the human body, and the unknown psychological effects of so much darkness. Although the SeaLab-1 habitat required a significant backup crew to get it to just the right place, once it was lowered into the ocean, the habitat's own small crew began to take over. The Navy's intention was to allow this crew to spend 15 days living in the habitat. They were lowered into the water to a final depth of 193 feet. Soon, the SeaLab was his crew's home away from home, The breathing gas inside Sealab 1 was different from what these men were used to breathing. It consisted of 4% oxygen, 17% nitrogen, and 79% helium. The Sealab 1 habitat, with an 85 average degree temperature, actually had many comforts of home. It had bunks and lockers and bathrooms. There was an oven and a refrigerator, a shower, and even air conditioning. One of the most interesting features of Sealab 1 was its bottom entry. It didn't have a hatch, nor did it need one, since the air pressure inside the chamber was greater than the water pressure outside. Once the habitat went below 200 feet, the sunlight began to fade, and the divers were subjected to a constant semi-darkness. Still, they did very well, as they didn't miss a beat in collecting data on marine life, selecting core samples, and setting up experiments. This project was also an endurance challenge. Once the crew members left the relative comfort of the habitat to explore the waters just outside their two 12-inch portholes, they encountered a significant problem. Because of the extreme cold, the crew could only stay out for 45 to 50 minutes at a time. It was, they reported, very tiring work, and they often returned to the habitat exhausted. Nevertheless, the Sealab crew was doing very well. However, on their 11th day of operation, a decision was made to terminate the experiment because of a threatening tropical storm 700 miles to the south. The Sealab 1 crew returned to the safety of the surface, and the project, although halted earlier than expected, was deemed a major success. It didn't take the Navy long to get back into action. The very next year, 1965, was the year Sealab 2 was lowered into the water off La Jolla, California. There were very few structural differences between the two habitats. The designs were similar. However, due to advances in technology, Sealab 2 featured a better construction overall. It was also designed to dive to a lower depth than did its predecessor. Sealab 2 was crewed with 10 aquanauts at a depth of 205 feet. One member of the team you might recognize was Scott Carpenter, the astronaut turned aquanaut. Each crew member was prepared to stay for 2 weeks before he'd be relieved by another crew member. Scott Carpenter remained an entire month. Since the helium in the atmosphere distorts a person's voice, the electrowriter became, especially at maximum depths, an extremely valuable tool. The crew's observation port provided hours of fascinating viewing. It was like their own private window to the sea's main street. It was 4 years later, just off the coast of Oahu in the beautiful Hawaiian Islands, that the Navy launched another habitat. This one, called the Ager, named for the Norse god of the sea, was established in order to better test and understand the ecology of the sea. It's located in the Makapu'u Research Center and was operated by the Mackay Range near Waikiki. The Ager was designed as a self-contained laboratory in which scientists and divers could spend up to 20 days at depths of 600 feet. The Ager held a major advantage over other habitats because it was portable. It had the ability to be completely disassembled in 24 hours, then flown anywhere in the world. Once it's been towed to the required spot in the ocean, the crew prepares to descend. On signal, the habitat's vents are opened, and the ballast tanks begin to fill with a massive rush of water, and the habitat begins to slowly submerge to the test depth of 80 feet. Sinking a craft like the Ager is not like sinking a submarine. There's no forward motion to help it go down, and it must be kept on a fairly level plane. Not only are the ballast tanks flooded, but weights are attached to the habitat to help it sink evenly. Once it's on the bottom, the ballast tanks are completely flooded to stop it from drifting. After it's inspected completely, the guide and mooring lines are cut away, and the Ager, except for power and communication cables to the mothership on the surface, is on her own. Once it's reached its place on the bottom, there was still a great deal to do. First of all, escape systems had to be checked out. The escape system carried 2 emergency transfer capsules, each capable of carrying 4 men. These chambers were designed as underwater ambulances to be used if people were ever injured or sick and had to be brought back to the surface for more specific care. Once everything had been properly checked, the diving team, which had been accompanying the habitat to the bottom, leaves, and now only the operations crew remains on the ocean floor to conduct the tests. According to the crew, it was a strange sensation to swim down through the depths, then climb up into a bubble of air. Yet the air in the habitat is still not the same air that people ordinarily breathe. It is a controlled mix of oxygen and helium that was developed in 1936. The Ager was divided into 3 chambers, one for diving, another for laboratory work, complete with a host of sophisticated onboard gathering devices, and a 3rd chamber called the living chamber, including a galley with a sink full of dirty dishes. The Ager was literally a self-contained world. It was a complex that contained a large variety of communications gear, a radio, a telephone, an underwater acoustic phone, and an electrowriter. In the Ager habitat, the entire crew was monitored very carefully while they continued to feed back information to the control center.
This control, go ahead.
Roger, we have our 0310 hour report. You prepared a copy of it.
What these aquanauts are involved with in the habitat is called saturation diving. In other words, at some point, the divers' bodies are unable to absorb more gases. Once saturation occurs, the amount of decompression time required at the end of the dive will not increase, even though the diver spends additional time at that depth. Although the mothership and control center watch the crew of the Ager very carefully, sometimes the unexpected goes wrong. And that's exactly what happened to this experimental habitat. You can see on the closed-circuit television the stream of bubbles from a rupture in one of the Ager's seams. This rupture causes a drop in pressure inside the habitat. Their first move to correct the problem was to stop the hard rush of water and increase the compression inside the habitat. Before they did, though, several divers swam out and checked the exterior completely for any other problems besides the split seam. In this case, however, nothing worked, and the pressure kept falling. A decision from the control center was made to abandon the project. Since the craft was relatively shallow, there was no real danger. Had the habitat been much deeper, the danger would have increased, and the habitat would have been sent up right away. Still, the command of this habitat viewed the Ager as a success. Failure, according to one of the comments reportedly made by the command post, can always teach you something. There was one vital aspect of the reality of living underwater for a prolonged period of time that continued to puzzle and haunt these researchers, and that was the question of what psychological problems might affect the aquanaut. Although researchers had been studying this problem since Sea Lab 1 was first launched, no one yet knew what such human isolation and confinement would actually do to a person. The question was not only being asked by the Navy. NASA had an interest in it too, because the habitat program so closely resembled the space program. So, with the combined efforts of the Navy, NASA, and the private company General Electric, TechTite 1 was created. It was essential that a meaningful scientific program be conducted on the sea floor to provide NASA with a realistic assessment of crew behavior. In response to this need, the Department of the Interior provided the necessary personnel and marine scientific expertise to conduct this seafloor program. The project, titled Tektite, borrows its name from the small meteorites, tektites, that survive the fiery plunge through the Earth's atmosphere and often come to rest on the ocean floor. The names symbolically link the program's oceanographic and space scientific interests. Yet aside from the interests that all three sponsors brought to this newest habitat, there was one especially essential issue they were concerned with. The Habitat program was searching for ways to extend bottom time and depth in a safe and cost-effective manner. The Tektite 1 was not only going to help find this out, it was also going to be the first long-term use of a nitrogen-oxygen breathing mixture in the open sea. The Tektite 1 seafloor program took place off the island of St. John in the U.S. Virgin Islands from February 15th to April 15, 1969, and was crewed by 4 aquanauts. The duration of the Tektite 1 program was to be 60 days, equivalent to space programs planned for the future, and by far the longest saturation dive to date. Although 60 days can virtually fly by, spending 2 months in a comfortable but crammed habitat 50 feet down can be a very long time. Although the Tektite 1 wasn't very large, its accommodations were very homey. The crew quarters included 4 built-in bunks, drawer space, a sink, a stove, a refrigerator, and a radio and television set. In other parts of the habitat were communication systems, a freshwater shower, equipment space, a toilet, and the electrical system. Just about every inch of space was accounted for and used for something. The aquanauts were required to perform several different kinds of experiments. The seafloor program was divided into 3 general categories: marine science, psychological issues, and medical research. As it turned out, the marine science program was over-planned, so the aquanauts had to choose which projects they wanted to do and which would have to wait for another time. But it was a psychological program that many of the researchers were especially interested in. In order to make the data more applicable to the space program, every effort was made to avoid any direct contact between the 4 aquanauts and people on the surface. Unless something went terribly wrong, the aquanauts knew they'd be isolated for 2 entire months. Psychological data was collected using 24-hour visual and auditory monitoring of the crew. This resulted in over 400,000 individual responses. Every minute the crew was eating, sleeping, or working, they were being watched and studied. The biomedical part of the program had 2 purposes. First, they wanted to see about the aquanauts' medical safety. Then they wanted to understand the psychological effects of long-term saturation exposure using a nitrogen-oxygen breathing mixture. In order to achieve this goal, the Tektite aquanauts were required to perform physical duties far more than in any habitat before them. They spent 432 man-hours in the water during the 60-day mission. Toward the end, they were spending as many as 5 hours each in the water. Although they were frequently tired, they performed well. However, as was the case in previous seafloor programs, the major problems centered around equipment failures. Tektite 1 encountered continual difficulties with the CO2 removal system, the TV cameras, the surface resupply system, and a myriad of other problems. Consequently, the aquanauts had to spend an inordinate amount of time repairing gear instead of conducting the planned experiments. However, the aquanauts themselves held up wonderfully. Their only physical problem were several ear infections, which caused each aquanaut to miss several days in the water. Finally, on April 15, 1969, after having spent 60 days in their habitat, the 4 aquanauts entered a pressurized transfer chamber. The capsule was lifted to the deck and mated to the decompression chamber, where these aquanauts underwent a decompression for 19 hours and 22 minutes. It was another successful operation. The 4 men did exceptionally well, medically and psychologically. The Tektite 1 operation learned a great deal from its 60-day dive. First of all, it was learned that aquanauts can live and work safely in a nitrogen-oxygen atmosphere. It was also learned that except for the ear infections the aquanauts suffered, there were no biomedical problems. Finally, and most importantly for both the deep sea and space programs, it was determined that long duration of this type appeared to be feasible for both civilian and military needs. In just 6 short years, from 1964 to late 1969, the undersea habitat experiments had achieved a great deal of success and had gathered for underwater scientists an enormous amount of research. Now, over 2 decades later, we see that this research was actually just beginning. So much more was and remains waiting below the surface of the ocean for men and women to explore. To the most curious and courageous underwater explorers, the answers to these questions are just waiting to be discovered.
The population of the Earth is expected to double within the next 30 years. Although we can only guess the consequences, we can be certain that it will have a profound impact on the future of mankind. If we are able to support so many people, we are going to need to better manage all the resources we can find, both on land and in the sea. The underwater prospectors of the future will not be grizzled old-timers working with picks and shovels, but multinational corporations employing highly skilled technicians and scientists. As we probe deeper under the ocean and uncover more resources, we will have to consider distributing them among all nations so we may provide the best possible quality of life everywhere on Earth. I'm Zan-Misέλ Κουστώ, and this is just one more of the Stories of the Sea.